Hello everyone, welcome to 60 Thoughts. Today we are going to discuss about show that greater than or equal is a partial ordered on the set of integers. Okay, so we have to why this relation is partial ordered set or not. So what is mean by partial ordered set? It satisfies three conditions. One is what? The relation set greater than or equal is a reflexive. Second one antisymmetric. Third one transitive. One satisfies three condition, then only it is this relation symbol is called partial ordered relations. Okay, so what is given, z, let z be the set of all integers. Here they given what? Set of integers. So we consider let z be the set of integer. Okay, so here capital R is nothing but we consider R equal to greater symbol. Okay, so what is our target? We have to prove z comma r. That means the partial ordered set form is called s comma r, right? S is nothing but z. Z means set of all integers. R is nothing but greater than or equal. Okay, so we have to prove z comma greater than or equal is a partial ordered set. Okay, so now we have to verify one by one. So before we verify one by one, we should know what is meant by z. Z is nothing but set of all integers. We consider from minus infinity to plus infinity, which means it contains from minus infinity to plus infinity, right? So here we are not verify all numbers, so that we have to consider any three variables. So using that three variables, we have to verify one by one conditions. Okay, first one, we have to verify the given relation symbol. That means greater than or equal is a reflexive or not. So it is a reflexive. What is the reflexive property? X comma x belongs to R. So here we consider a greater than or equal to a. Otherwise we can write a comma a belongs to R. R is greater than or equal symbol. So if we consider a equal to any integers, if we consider a equal to 1, so 1 comma 1 belongs to the relation set R. So here also, here I am not relation set. Why? Because your given set is what? Infinite set. So relation set also we get what? Set of all ordered pair, which means we get infinite number of ordered pair. So that we are discussing all three properties with A, B, C only. So for A belongs to Z. If we consider A equal to 100, what is your relation set? 100 comma 100. It is also belongs to relation set greater than or equal. Therefore, it is reflexive. Second one, we have to verify antisymmetric. So here the given relation set is antisymmetric, because if A greater than or equal to B and B greater than or equal to A, then we can write what? B equal to A and A equal to B. For all A comma B belongs to even relation set is transitive. You see the condition, if A greater than or equal to B and B greater than or equal to B. So using these two order pair, we can write A greater than or equal to C. For all A comma B comma C belongs to Z only. So therefore, once it satisfies these three conditions, therefore the given relation set is called partial ordered relation, not partial ordered set. How to write partial ordered set? That is nothing but the S comma R is called partial ordered set. It is denoted by S comma R. Here S is nothing but set of all Z. R is nothing but greater than. So therefore, hence Z comma greater than or equal is a partially ordered set. Otherwise, Poset. Once it up to this, we can say that what? Greater than or equal is a partial ordered relation. Once this form is called Z comma greater than or equal. This form is called partially ordered set, otherwise Poset. Okay, so I hope you are enjoying session. Thank you.